YouTube. My name is Stan Pacusa, alias Stash Poshensky, also known as Pineola, and I'm here to demonstrate this 10 by 18 wood lathe conversion to metal.
Ways are a whopping 4
I started by checking out the bed thoroughly. Found it to be well made, cast iron throughout. The ways were milled top and bottom and parallel to about 2/1000ths, measured from tailstock to head. Machined the receiver and the cross slide, but borrowed the compound from an Asian lathe. The carriage assembly follows the channel by means of a guide block at the bottom of the receiver, mortised into the receiver. With a lock plate securing the guide block to the bottom of the milled way. The cross slide was designed to accept the Asian compound. The receiver and cross slide were designed thicker, both for strength and to gain some additional height because of the tall headstock spindle. I'm using a riser block here under my tool rest to gain the additional 1 inch or so additional height. There is absolutely no play in the receiver. There's no rock, there's no side play. There's no lift. But yet the movement is smooth. It slides with very little effort. To lock the cross slide, you simply reach under and there is a nut there with a lever that would lock the cross slide in, lock the carriage assembly in any position along the ways. "3.5 inch travel on the cross slide or more. A very smooth operation. The bearings are solid aluminum and machined to match the contour with 7-degree angle of the lathe profile. Lead screw is 3/4 10 and kept short between the bearings for maximum rigidity. There's about 22 inches between the bearings. The half nut was designed to be simple but yet effective. It's nothing more than a 3/4 nut welded to a 1/4 thick by 1 inch steel bar and slotted to allow up and down movement, up to disengage and down to engage, with a wing nut used to lock it in position. This will be changed to a lever eventually. When engaged, there is absolutely no slippage and very dependable. None of that printed thread crap as mentioned on that ginger snap lathe. Here's the machining of the factory faceplate. What we're doing now, we're going to take this factory supplied faceplate that comes with the 10 by 18 wood lathe. I'm not going to be cutting any wood with it, but I will be cutting metal. So I want to mount a chuck. And this adapter here, this faceplate, will make an exceptional adapter for chucks, for any chuck, any Asian chuck. And what I'll do now is cut a registration boss. I'm cutting cast iron, and so far no chatter. See how it goes. Looking pretty good so far. Sounds pretty good. Check back later after I get the size. Don't want to cut too much. The registration boss is 2.17 diameter by 114 deep. So that's what we're going to shoot for.
That's 0.14 deep.
Here's a heavier cut to see what this lathe can take. Doing good so far. Okay, time to measure. It looks pretty good. We'll try it. See how it fits. Perfect. It's on there. No, I didn't feel any slop. It's not moving one way or the other. So that would be how you mount a open face chuck when you haven't got a 1" 8 chuck, and I haven't got a 1" 8. But that's why I turned the factory supplied faceplate to that. Now all I have to do is drill 3 mounting holes accurately, and should be in business with that. Here is a faceplate. You have plenty of room for your fingers to remove the chuck. Plenty of room. I used to dread changing the chuck on the mini lathe, mainly because I had to use tweezers to try to get the bolts in. It was a job, dropping them on the floor and so on.
Correction.
Here's just a simple matter of removing the bolt. Oh, another thing, when you tried to unscrew the nuts on the 7x10 mini lathe, the studs would come with it and jam all the time. It was a pain in the neck. Here you have all the room in the world. I'm using full-length studs that come out in one piece. Very simple. The motor was mounted externally. Showing the opposite mounting for the motor. That I could mount a larger outboard pulley to the headstock. I felt the speed offered were just a little too fast for metal cutting, and I wanted to slow it down. Here it is in operation. I'm using a stretch rubber belt. Both pulleys are two-step and give me about the speeds that I need. Sorry I'm not wearing my white gloves. Maybe Morgan will let me borrow a pair. I'm leveling right now to make a pulley. A wooden pulley. Don't look bad to me. Let's do the center.
Tool deflection is not an issue. This recess will allow the pulley to mount closer to the headstock, which I need to line up properly with the motor shaft.
I'm trying to get my depth now. Then I'll worry about the diameter. The headstock flywheel was used to mount the homemade wooden pulley. Took a little bit of machining to do so, but became very effective. Here's the machining coming up next for this homemade chuck adapter. It's solid aluminum with the Morse taper shown that was poured all in one piece. The adapter is reinforced with a 5/16 steel rod.
The Morse taper is reinforced with the rod.
The mounting holes have not yet been drilled, nor has the back been faced. Truing up the diameter. Well, we'll fast forward to facing it off and cutting the boss for the chuck. See you then. Well, we're turned to 315 diameter. Now it's time to face the front and do the registration boss. Let's cut the registration boss. Well, there you have it. It's done. Now you can mount a faceplate. There's absolutely no rock in that plate. Okay. All right. Just a demonstration, turning a bar between centers. We'll put some centers in this threaded bar. and go from there.
Cutting a threaded rod, tool is skipping between the thread, as a result, thumping noise. Here's a facing demo.
Right on center. Well, there you have it. You've seen me turn wood, cast iron, steel, aluminum. You've seen me face cast iron, steel, aluminum, wood. You've seen boring operations. You've seen turning operations. You've seen facing operations. You've seen the basic. Okay, that's about it.
Good night, Mrs. Calabash, wherever you are.